Hi, it's Mr. Burke here. I'm just going to take you through a first video, the fourth video in a series on quadratic equations, but the first on completing the square, which is a really good way of solving quadratic equations. So hopefully you remember from the last video, number 3, that if we can get a QE, which stands of course for quadratic equation, just to save space on the board, if we can make a quadratic equation look like this, where we've got x plus a number squared equals a number, or x minus a number squared is a number, then we've seen that we can find a solution using plus or minus square root. Plus or minus is very important because it gives us two solutions. Remember the parabola. So why should we use this quite complex method of completing the square? Why? Because we can solve quadratic equations. We can use completing the square to solve any quadratic equation that looks like this, and I've shown you some examples here. The main thing is just that the coefficient, as we say, of x squared is going to be 1. As long as we can get the coefficient of x squared is just 1, it's not multiplied by a number either positive or negative, then we can use completing the square and see what answers we get. Remember, we could get 2 answers, occasionally 1, and sometimes there are no answers. Alright, and the other thing to mention is with a little bit of algebra that you have done before, you could divide both sides, for example, in any quadratic equation and make the coefficient of x squared or y squared or whatever it is into 1. So that's another reason why completing the square is really handy. So let's move on. How do we do it? So there's a few steps to completing the square. The first one is we'll just remind ourselves of the FOIL method. So you may remember that FOIL stands for first, outside, inside, last. It's just a nice way of remembering that when you're expanding grouping symbols, that you can use this method. So of course we know that we can write x plus 3 all squared, which is what we've got here, as x plus 3 times x plus 3. So let's choose some colors. Let's choose red for the first. So to get rid of the grouping symbols, we have to multiply first by first. So that's here, x times x, and that's going to give us x squared. Okay. Alright. Choose this purpley color for the outside. So that's going to be these two. And that's going to give us a second number, which is 3x. Okay, choose another color, green, and we do the inside. So the inside is this one and this one, and that gives us another 3x. That's the really important thing to notice. And then the last one is the last. The last in the first lot of grouping symbols times the second one. I've chosen the wrong color.
Dad's at the front waiting for you. Would you mind making your way to the front of the school to meet your father? Thank you.
Okay, sorry for that interruption. And let's choose this color for that one and remind ourselves that green was the inside. So the last times the last, this again is an important one, 3 squared, which is 9. Okay, so, and of course we can rewrite that as collecting like terms, x squared plus 6x plus 9. Okay, so the next step is so important that I'm going to show you on the next slide another way of looking at that. But just notice that we got 6x here because we added the two 3x's. So again, it's really important, so I'll show you this another way. We can all write this another way. Maybe you've seen this before. We've got the x and the 3 in one of the grouping symbols, x and 3 in other grouping symbols. X plus 3 times x plus 3. And we're just expanding that. So here, when we do our first, we get x squared. When we do our outer, we get 3x. We do our inner, we get another 3x. And we do our last, we get our 9, our number. Okay, so again, just see we've got these two here. Because we have the same in both lots of grouping symbols, we always get this doubling effect. We always get these two are always the same when we're squaring. When we're squaring the same thing in the grouping symbols, multiplying it by itself. And so, if we, the second point here on the screen, if we halve the coefficient of x, that's one thing to do, and square it, that's the number we need to complete the square. In fact, we need two numbers, but that is the important number. And this number here also tells us something. So we'll see that more as we move along. So let's complete the square. Do an example here. Alright, so what we want to do is we want to find the coefficient of x is minus 20, careful, and then we half of minus 20 equals minus 10, and that's one of the numbers we need to know. And we also square that number, so minus 10 all squared, important with quadratics. Remember, minus times a minus is a plus. Minus 10 all squared is 100. Okay, so this means that we now have the two numbers we need. Those are minus 10 and 100. So that means that we can just write that x minus 10 all squared equals x squared minus 20x. And this is where, remember, when we're completing the square, we have a question mark. What's going to be the number here? And the number we found is this one, plus 100. So two things connect here. Where did we get this number? That was from here. Halving the coefficient of x, and we got minus 10. And then we squared that, and we got the second number, this one. Okay, so that's a bit tricky. Until you've done a few, then you get it. So the next thing I suggest is maybe pause the video, write that example down, and then if you don't quite get that yet, there are a few more steps here first. So you might want to pause the video, write these steps down. These are actually the full set of steps. The only things that you really need to do at the moment is the steps here in modified form. So, as I said, if you want to just do that first step of completing the square without solving the equation, then here are some exercises you can do. Otherwise, go on to the next video, which is Quadratic Equations 5.